Good afternoon, all the students. Just wait for 2 minutes. mute yourself. Please mute it. Mute it. All mute it. Please mute it all. Yeah, all the students, yesterday we already discussed about what is the acceleration, what is the velocity, and as well as what is the gravity. Yesterday we already discussed it. Okay, now yes, now we are going to discuss about the remaining concept, whatever equations of motions for a gravitational body under the gravitational effect, how the body is behaves and what is the equation of motions for it. Okay, you know very well. Yes, that is the equations of motion for equation of motions for regularly, whatever the linear motion that is taken as what v is equal to u plus at. Okay, clear or not? One is the equation, and as well as we are taken s is equal to ut plus at square. Another equation. Okay, and as well as b square minus q square is equal to 2as. This is also called equation of motion. Sn is equal to u plus a into n minus 1 by 2. As in our textbook, they given, or it is also written as u plus a by 2 into 2n minus 1. There is a mathematical conversation only. These are called the what? Equations of motions. Clear? Okay, now for which body? For a linear body. Means what? When the body is moving like this here. Okay, clear or not, all the students? When the body is moving in a linear mode. Okay, clear? Now, not like this. It is suppose the body is not moving in this particular form. There is a what? One body is coming from some particular height. Okay, clear or not? Yes, some particular height, freely falling body, which is called which is coming from some particular height. It is called what? Freely falling body. Okay, now example is okay when there is a one book is a fall from the second floor. Okay, now one brick is a fall from the second floor. Otherwise, when one body hit by the cricketer, okay, now it reaches to some particular height, and again it will be come down. And when it is started the down path, it is called what actually? It is called a freely falling body only. Okay, clear or not? These are the about what actually? This is about what? This is about freely falling bodies. Got it or not? This is about a freely falling bodies. Yes, and here there is we consider this freely falling body moves in this particular direction. This is only called what? Acceleration due to gravity. Okay, now yes, at that time there is a body contain one acceleration. That acceleration is called, it will be contain acceleration in this direction, but there is it is a contain acceleration in a down direction. This is only called what? Acceleration due to gravity. Okay, now why the body is coming like this? The soft piece is coming like this. From here to here, it is coming like this. How it is possible? The duster now coming from here to here. How it is possible? Who made it is? The earth is contains somewhat a gravitational force, and that force is only gives acceleration. That acceleration is only called what? Acceleration due to gravity. This acceleration is only called what? Acceleration due to gravity. Got it or not? Yes. And here there is this v value, whatever there here. This is changes these equations. Okay, how? In these equations, there is you have to substitute in the place of a g, the positive g only. Okay, clear or not? Yes, we have taken plus g only. Okay, sir, why you said it is a plus g? Somewhere we are using minus g also. Okay, now when the body is in the direction opposite to the Yes, gravitational force. Now I'm okay now. This is from here to here. It is a called what? Opposite to the gravitational force. At that time, you take a minus g. Acceleration due to gravity is taken as minus g. Now you take a is as a plus g. Got it or not? A is as a plus g. And here u is as 0. U is taken as 0. Why? Because we not given any acceleration now. We are not given any velocity to it now. We are given any velocity. We are given any velocity to it. Suppose I am okay now. Yes, thrown up this body. When I am given here some velocity to it, but I am given any velocity now. No, I am not given any velocity to this chalk piece. It will only fall down. Got it or not? That is why the velocity become what here? 0. Yes, the velocity is what here? 0 only. Okay, now which velocity? Initial velocity is a 0. The final velocity is not 0. It is taken as v only. You know very well. U is a called what? Initial velocity. V is a called what? Final velocity. Okay, clear or not? This is the final velocity. V is equal taken as v only. Here, normally started at A and it is a reaches at B. This distance is a called what? This distance is the called what? Yes, yes. Okay, now the traveling distance is indicated by yes, but it will be traveling distance the what? Height. Okay, now that's why here s is equal to you take it is as h. Understand all of? Yes, and the time there is no change in the time taken tu. Now, whatever the values are there here, that values you have to convert it as like this. You get the equation of motion for a freely falling body. Okay, clear or not? Now you get the equation of motion for a freely falling body. Equation of motion for which one? For freely falling body. Freely falling body. Got it? Now, what happened it is? Now, there is a V is equal to taken as what here? V only. What is the U value? Here 0. Okay, now clear or not? 0 plus what is the A value? It is a G. What is the A value? It is a G. And what is here? T. V is equal to taken as GT. V is equal to taken as GT. Got it up? Now, next. What is the S here? H. S is a what here? H. And what is the U value? 0 here. 0 into T plus half. What is the A we have to write? G. Okay, now it is become what? GT square. 0 into T what it here? 0 into 2 T what? 0 only. Okay, now something you multiply with the 0, it will become 0 only. Okay, now it will become what? Half GT square. Then what is the equation become now? H is equal to half GT square. Got it up? S is equal to what? Half GT square. Now V square minus U square. What is the 0 here? Third equation. 0 square. It is equal to what we have? 2AS. 2GH. Okay, now it will become what? V square is equal to 2GH. This is another equation. This is another equation. This is another equation. Got it? These are called equations of motion. Suppose you want to find out the height of a body at a nth second. What is the? Suppose it's a traveling path totally 8 seconds. We want to height of a body from okay now at the 7th seconds. Okay now at that time you use the formula by using it. Okay, how we write it is h in the place of s. What you have to write? Hn is equal to what? U. U is the what here? 0. Then what is the a here? G. Yes, what is the n is not changes like that. G into n minus 1 by 2. These are the equations of motion. I hope you got it, all the students. Okay, now simple thing you have to substitute. Okay, now in the place of a these values, in the place of a g, the place of u 0, In the place of B, B. In the place of H, H. In the place of T, T. In these equations, you'll get the what? This equation of motion for a freely falling body. Simple thing only. Okay, just you have to substitute these values in this linear equations. Got it? I hope you got it. There is once you write it, already yesterday you complete this. Okay, now this is the current equation of motion for okay freely falling regular linear motion. Yes, yes. These values are substituted in equation 1, 2, 3, and as well as the 4. Here you have to write here equation 1, 2, 3, and as well as the 4. We get the equation of motions okay for a freely falling body. Please write down it is totally. Write it. Any doubt?
सेकंड क्लास को खोल ले
Fatima madam, please mute it. Yeah. Also students, there is what we are consider very it is on the third equation. Sorry. And here the fourth equation is the what? Sn is equal to S. What is that? H is equal to S. Hn is equal to taken as okay 0 plus what it is u in the place of a you can consider n minus 1 by 2. That is Hn is equal to taken as G into n minus 1 by 2. This is the one more equation. This is equation number 4. These 4 are called equation of motion for a freely falling body. Yeah, I want to take it in our box. It is a very important for you for solving the problems. Got it? Yes, I hope you got it. The first one is V is equal to yes GT. Yes, and the next one is H is equal to of GT square. Yes, and V is equal to under root 2GH. H is equal to yes G into n minus 1 by 2. Yes, these are called what? Equations of motion for a freely falling body. Okay. Got it? Now there is an example is there. Okay, now yes, you get idea how to we are use this kinematics for us. Okay, now yes, once check it. The page number where there is on a 48. Page number 48 we have it. Okay, once check it, there is what they given. When a body is dropped freely from a height, sorry, a body is falling under a gravity. Find the distance covered. Distance covered first, second, third, and a fourth second. Okay, clear or not? What they given? Yeah, they given like this situation. What is that? Yeah, body. What is the body? We have taken a ball here. Okay, the ball is falling under the gravity. Okay, now yes, it will be under the gravity. It will be falling. Yes, yes. What is the height it will be traveled? What the find the distance covered in a first second? Which one? Yes, in a first second, how much distance covered? In a second, how much distance covered? In a third second, how much distance covered? Which formula we have to use? This is only the traveling distance for a nth second. Okay, now for every nth second, how much it is? Here, there is a what? The initial velocity for that body is equal to what here? U equal to 0. Then fundamental formula is a what? Sn is equal to the traveling distance is equal to taken as Sn is equal to U plus A into n minus 1 by 2. Okay, now clear or not? Yes, or otherwise it is also taken as U plus this A by 2 into 2n minus 1. Okay, here what is this n? N is the which second? Nth second. Okay, but here not A, here not U. Here U is a what? U is a 0. A is equal to 0. A is equal to G. Okay, now you have to get there is a now Sn become what? Sn is here and Sn is equal to what? H here. Okay, clear now? H is equal to what? H is equal to Hn is equal to taken as what it is? U is become 0. G A is become G. G by 2 into 1 2n minus 1. That is only we get. Hn is equal to taken as G by 2 2n minus 1. Okay. What they ask for first one? Okay, now first second. What they ask for us? Second or first second? Yeah, first second they ask for us. Okay, now h is equal to the ask for us. What it will become? Okay, now here g is equal to how much? Here g is equal to 9.8 meter per second. This is the called acceleration due to gravity on Earth. Okay, it will be varied. Moon, it is the 1.6. On Earth, on Sun, it is the 29.4. Okay, clear or not? Like that, we have taken the values. Here, h is equal to taken as yes. First one 9.8. First second means what? 9.8 by 2. Okay, what is the 1b here? N is 1 minus 1. It become 1. H first second is equal to 9.8 by 2. 2 into 1 minus 1. What is that? 1. Okay, clear or not? Now it become what? 9.8 by 2. It is a 4.9. Okay, now 4.9 meters. Got it? When it is started here, after 1 second, how much distance it travel? 4.9 meters it travel. Got it? And next, after this, H second here. Second. H second. What is that? G is how much? 9.8 by 2. Okay, and as the last 2 into second how much? It is like that we are consider 9.8 by 2. That is a 4 minus 1. It is become what? 9.8 into okay now just 3 by 2. Okay, clear or not? Now 4.9 into 3. It is taken as a 4.9. Clear or not? 4.9 into 3. How much it is? 4.9 into 3 is a 27. Okay, clear or not? As 3 into 4, 12, 14.7 meters. In a second, how much distance it travel? 14.7 meters it travel. Got it or not? Now, next, third second. What will we get simply? Yes, there is again you have to draw. There is a 9.8 by 2 into 2 into what is the third second? Na? 3 minus 1. Okay, clear or not? Now it is about a 4.9. You know very well. 9.8 by 2 is about 4.9. This is a 6 minus 1, 5. 5 into 4.9. 5 9 the okay na 45. Okay na there is a 4. 5 4 the 20. 24.5 meters. Got it or not? Like that, it's a traveling distance. Suppose up is from here. After 1 second, how much distance is the travel? 4.9. Okay, clear. After 2 seconds, how much it's travel? 4.7. In case it is not touched with the earth. Okay, now in case it is at the third second, 24.5. Like that, only 4th second. Like that, only 5th second, if it is possible. You have to find out what is the traveling distance in the flights. Clear or not? Understood all of it. In 1 second only, this surface is travel how much distance? 4.9 meters. Got it? Yeah. Note down. Note down it is. First you have to write here. First part, second part. All the students, these are the physics problems. Please take a past copying. Otherwise, all the teachers, please take a one screenshot or a photo. Okay, for your students' purpose, please take a one screenshot or a photo. Why? Because only one problem only completed till. Yeah, now we are going with that whatever conceptual practice sheet is there. This 26 we have examination. In this examination, this lesson may come for you. Page number 49. Yeah, one second. There is a conceptual worksheets are there. When a body droplet freely falling from height, its initial velocity u becomes. What is its initial velocity? When a body is a droplet freely fall from a height, its initial velocity u is become. What it is? 0. Okay, now already we are discussed now. Okay, now when our body is started from here, what is its initial velocity? It's a 0. No need to give an initial velocity. It is on itself. It's a drop towards the earth because of gravitational force. Okay, that's why there is equation. There is a first one. It is about a 0. Yes, second it is okay. The force which the earth pulls the object towards its called the. Okay, now once again, the force which the earth pulls the object towards it is called the. What it is? Gravitational force. Okay, second one is what is the gravitational force. Already you know very well. In your first lesson also it is there. Gravitational force. Gravitational force. Third point. Next, a body strikes the floor vertically with a velocity u and rebounds at the same velocity. The magnitude of change in a velocity would be. Okay, once again I repeat it. The body strikes the floor vertically with a velocity u and rebounds at the same velocity. The magnitude of change in velocity would be. Okay, any change is there here. The same velocity here we consider now. The body strikes the floor vertically with the velocity u. What they said, it's a rebound at the same velocity. Initial velocity is equal to final velocity. This is called any velocity change? No. There is no change in a velocity. What will be the velocity? Velocity change is 0. Okay. The third answer is 0. Again. Fourth. Acceleration due to gravity g in a centimeters per second square. Yes, it is a 980 centimeters per second square. And what is that? 50.9.8 meters per second square it is. Got it? This is only about the S acceleration due to gravity values. 9.8. How this value is a 9.8? Okay, now yes, you required it is. Okay, it will be already there in a 70 class IIT textbook or otherwise 90 class regular textbook. Yes, once ask your brothers and sisters. Okay, now the 9th class also not there, but 9th class IIT foundation class again. Okay, now yes, but you why not it? Not a problem. You'll get it in your future. Yes, why? Because we have one formula for the G. G is equal to Gm by R square. In this one, you have to substitute the gravitational constant. That value is 6.6 into 10 to the power of -7, and the mass of Earth. Okay, now mass of Earth is, you want to write it, 6 into 10 to the power of 24 kgs. 6 into 10 to the power of 24 kgs. Mass of Earth. Okay. Yes, and the radius of Earth. Okay, this is the circular. What is the radius of Earth? 6,400 kilometers. Okay, from the surface here to here, how much distance is there? 6,400 kilometers. That is the center of Earth. Okay, that much of depth is there from our foot to Earth. How much depth is there? 6,400 kilometer depth is there. Our oceans are contain only 11 kilometer depth only. Below the ocean also Earth is there. Okay, how much? 6,400 kilometers. Okay, you want to go for it? Huh? Yeah. In case you go like that, not again comes towards Earth. Okay, now? Huh? Yeah. There is a what? It is a what? Actually, a conceptual question answers. Next, level 1 questions. Level 1. The distance traveled by a freely falling body is proportional to the distance traveled by a freely falling body is proportional to what it is. Once again, I am repeating here. The distance traveled by a freely falling body is proportional to. Yeah, there is a formula you have to require. One, take the second equation of motion. What is the second equation of motion? H is equal to half dt square. This is proportional to which thing? Okay, clear or not? Here, the first question. S, H is, this is a constant or not? Of, there is a 0.5. G is also constant. Then it is also written as T square. Okay, now H is proportional to which one? T square. The given or not? Yeah, the given here. One second. The mass of the body, the square of the acceleration to gravity, the square of the time of fall, the time of fall, the square of the time of fall. What is this T square? The square of the time of fall. T square. Which one? Time square. Yes, the square of the time of fall. That is only. H is the directly proportional to T square. The answer is what? C. First answer is what? C. Yeah. Next, second question. Two stones of a different masses are dropped simultaneously from the top of a building. Then which is the correct among these? Okay, tell me. Yeah, both are reached at same time only. Yes, you know very well the Galilean experiment. Okay, on Pisa Tower. Okay, he taken a feather, he taken a coin. Yes, both the same time he sent it. He make it is a fall towards Earth. Both are reached at the same time if there is no air resistance. No resistance, no friction of any other things. Yes, the bodies are reached the same time, whatever its a mass contained by it. Why? Because the acceleration due to gravity value is a constant. The gravity on the bodies is not depending on the body's mass. Okay, clear or not? Why? Because G, the small g value is what already given. G is equal to Gm by R square. Here M is not a mass of the body, which is the fall down. Suppose this is the Earth and this is the mass of the body. Okay, now this small m is the mass of the body, it is the capital M of the Earth, and there is a what? Earth center is the R here. It is not depending on the mass of the things. It is a depending on the mass of Earth. It is a depending on the distance between the body and also the Earth. That's it. Got it or not? Yes, it is not depending on the mass of the body. Either maybe large stone or maybe big stone or maybe anything. Both are reaches same time only. There is no change in that. But sir, why there is all the things are not looks at same time? Why? Because yes, our environment is a contain what? Air. That air is given resistance. Air is given pressure. In case the nothing will be there, they what? They are reach the same time to the earth. Same time at earth. Okay, clear or not? It will be not vary. Either may take large stone or may take it is a yes any other. Suppose you take this top piece and this duster. The same reaches the same time to the earth. Okay, clear or not? You imagine that duster is the slow down, the piece is the fast. Correct only according to you. It is a lighter mass, that side is the easily reaches to the earth. It will be take some time. It is a correct or is a contain more mass, that side is reaches the less time. It will be take a lot of time. That is only your idea. Correct or not? No, it is not a correct. Whatever the mass of the body it is there, it will reach the same time to the earth. Okay, why? Because G acceleration due to gravity is independent of mass. Okay, clear or not? G is not depending on the mass. Okay, yes, that is only how to write it. There is a what is the answer? Second answer is larger stone hits the ground earlier, smaller stone hits the ground earlier. Which of the stone reaches the ground earlier depend on the composition of the stone. Not it is none of these. Okay, it is not depending on the any other thing. Either maybe cotton or maybe iron. Okay, whatever maybe it will be reached at the same time. The answer is none of these. Answer is second one. Answer is B. Yes. Next, after this, a coin and a black iron dropped from the same height at the same time. Okay, which one of the first reach the ground? Yes, answer is B. Now only we discuss. The both are reached same time only. Okay, now answer is C. Third one answer is C. This is only today's class, students. Tomorrow you are going with the discussion of the problems on a level 1 and level 2, whatever there here. Okay, now you get the physics kinematics problems. Okay, now it's a very important. You get a lot of confidence when you are complete the problems in a physics, numerical problems in a physics. Okay, don't miss it. Yes, physics problems are very easy. If you are habited the done the physics problem in every subject, you'll get the good knowledge. Okay, clear or not? Why? Because physics problems are contained very analytical in manner. Okay, clear or not? You are compare the things of the mathematics and as well as the physics at a time. Okay, everything will be yes, it's a mind puzzles actually. Okay, now that's why your mind thinking power is also increasing. Don't miss it. Okay, now yes, it looks somewhat hard, but initially it will be hard. Once you habitate, every day you require that. Your mind is bought it. Okay, clear? Yes, thank you.